So this will be the last exercise for the indices that we've been talking about all along if you follow all the previous videos. So we have 3 raised to power 2x plus 1 plus 26 into 3 raised to power x minus 9 equals to 0. We are going to follow the same approach that we did in previous examples, and the goal is to be able to apply the laws of indices. So where we have the plus, we use multiplication. Where we have the minus, we use division. So let's start with the question you are seeing on the screen. So we have 3 raised to power 2x multiplied by 3 raised to power 1 plus 26 into 3 raised to power x minus 9 equals 0. So now, you look at this one that says 3 raised to power x, we can break it into 3 raised to power x into 2 multiplied by 3 plus 26 into 3 raised to power x minus 9 equals 0. So now we can rearrange the equation better by bringing the coefficient forward and have 3 raised to power x raised to power 2 plus 26, and then we have 3 raised to power x minus 9 equals 0. We will not want to continue with a 3 raised to power x because it will be too much work, since that is what you want to determine. So to simplify the effort, we'll say let 3 raised to power x be any variable. So in this instance, we are going to pick a. So anywhere we see 3 raised to power x, we are going to put a, and that will be 3a squared plus 26a minus 9 equals 0. So now we have another quadratic equation. To solve this quadratic equation, we need to look for two factors. That is, two numbers that if we multiply them will give us 26. Either we add or subtract, it should give us 26. So how do we approach this? We look at the first coefficient 3 and the last coefficient 9. So if we multiply 3 by 9, it will give us 27. So now let's play with this 27 and see what it's going to give us to be able to determine the factor for this equation. So I'm going to say, what is the factor of 27? So 3 we go, we have 9, and 3 in 9 we have 3, and 3 here we have 1. So if we want to break down the factor, 3 times 9 will give us 27, and then we have 9 times 3 will give us 27, and then 9 times 3 is 27 times 1. So as you can see, we have these 3 sets of factors that we can multiply that will give us 27. The next question we'll be asking is this. We have this middle number 26. What two numbers here from this side can we add or subtract together? So we look at the numbers that we can add or subtract together that will give us 26. 3 and 9, 9 and 3 will not, but 27 and 1 will. So let's play around with 27 and 1 to see how we can arrive at plus 26. So we'll follow the same pattern. We have plus, 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 minus, minus, plus, minus, minus. So we have 27, 27, 27, and 1 in each case. So what will be the outcome? So plus 27 plus 1 will give us plus 28. That's not what we are looking for. Plus 27 minus 1, that is, you have 27 and you are owing 1. That's plus 26. This fits our picture. And this will be minus 26, and this will be minus 28. None of this meets our criteria. The only one that fits our criteria is plus 27 and minus 1. So now we've seen what we are looking for. Then we transfer 3a squared plus 27a minus a minus 9 equals 0. So it's as if we are saying 27 minus 1. So from here, we have breaking into 2. So we have 3a squared plus 27a minus a minus 9. Then we have that one also equals to 0. So in this instance, we want to see what is common to both sides. If we look at it, 3 is a factor of 27 and a appear on both sides. So we can transfer 3a. The question we ask next is, what do we multiply with 3a that will give us 3a squared? And that will be a. 3a times a, that will be 3a squared, because this is raised to power 1. This is raised to power 1. This also raised to power 1. Now, we have plus. What do we multiply with 3a that will give us 27? If you look on the right hand side of the page, we have 9 times 3. So that will be 9. So we have 9 times 3 will give us 27. Now, this is where it gets tricky. We want to have our minus 1 here. What do we multiply with a that will give us a? It is still 1. And here we have minus. So minus times minus, that will give us plus. And that will still be 9 equals to 0. So we want to take just one of these factors of 3a, a plus 9. So we have 3a minus 1. And then we have a plus 9. Now we can solve for a. So let's take them one at a time. So solve for a. So we have 3a minus 1 equals 0. Because we want to separate this minus 1, we'll say add 1 to both sides. And if we do that, this will be 3a is equals to 1. Because minus 1 plus 1a on the left hand side will be 0. And we want to find the value of the variable a. We'll say divide both sides by 3. So we're going to divide both sides by 3, and that will give us 3a over 3 and 1 over 3. So on the left hand side, 3 will cancel out, and we are left with 3, 1 over 3, or 3 raised to power minus 1, based on our law of indices. So we have 1 over k raised to power n, k raised to power minus n. And then let's take the second one, which is a plus 9. So we have a plus 9 equals to 0. So that will be a is equals to minus 9 if we subtract 9 from both sides. So in this instance, because the value of a, which is a 3 raised to power x, must be greater than 0, this one has no solution. So no solution because this is less than 0. All our value of 3 raised to power x must be greater than 0. But let's go back to the first one, which is a 3 raised to power x equals to 3 raised to power minus 1. So from here, we have x equals to 1. So therefore, the value of x is equals to minus 1. So that is the only value. Thank you for watching this video. And please subscribe. Thank you.